May I invite Marianne Hagaseth, Senior Research Scientist with SINTEF Ocean, to deliver the presentation on ship-shore interaction, the model in the middle. Go ahead.
Hello, my name is Marianne Hagaseth and I work as a senior researcher at SINTEF Ocean in Trondheim, Norway. Here I will present a paper about the exchange of information between ships and ports, and especially how to ensure correct and efficient interoperability. This paper was written together with PIMCO, which is the largest organization for ship owners, and also together with the International Task Force on Port Optimization. Both of these organizations have been very active in the standardization of data related to just-in-time arrival to ports and the efficient execution of port and ship services. The starting point is a ship sailing between ports in different countries and continents. Before, during and after each voyage and port call, the ship needs to exchange information with several stakeholders. The same information are requested by different stakeholders, but with a slightly different usage. There is clearance information to the port state, customs, and in Europe also to EMSA as well. Before the port approach, the port authority or possibly a port ETS must give clearance to enter the port area. Also, during the sea passage, reporting must be done to specific reporting areas as defined by IMO, for instance, in the Baltic area, the Barents Sea, in Singapore, and 20 other areas. At some time before the port approach, the ship must exchange information with the terminal on where to berth, what ship and port services are needed, and also information about the cargo to be loaded and discharged. In addition to this comes a communication with other ships, with the ship operator or charterer, and also with external providers of ship services to support the voyage and port approach. It's important to improve the quality and availability of this data and to harmonize the standards to allow reliable and efficient information exchange between ship and shore systems. There is an overlap of information needs, both in the mandatory reporting to authorities and in the information needed to ensure efficient just-in-time arrival, timely execution of port services, safe navigation to port, and automation of cargo operations and the mooring process. The data exchange is more and more digitalized, which means that the interoperability among systems must be ensured. Examples of systems are port state clearance to maritime single window systems, clearance to customs systems, more automatic handling of port and ship services, union reporting, and also electronic charts for port areas and other systems covering information related to the port assets. A lot of the information is common for the domains, which means that we need to have an agreement about the semantics for this information. This is indicated by the gray area in this figure. Examples of this information are information to describe the location, information to describe the timing, and also information to describe the services performed before, during, and after the port call. An important contribution to the model in the middle comes from the work done by the International Maritime Organization, IMO. They have developed a list of data elements with a unique semantic and format, and also a related conceptual data model. This is done in cooperation with the World Customs Organization, the United Nations Economic Commission for Europe, and the International Organization for Standardization, that's ISO. In addition to this, the work is done in cooperation with a large number of maritime and other organizations through the IMO, for instance, PIMCO, International Task Force on Port Optimization, IEC, IALA, EU, and EMSA. The original purpose of the IMO reference model was to ensure interoperability between government-to-government data exchanges, international trade exchanges, and ship operational data exchanges as defined by the FOL Convention. Later, the scope has been extended to cover data for ship certificates with input from IACS, that is the Organization of Class Societies, data for port state control, and data for just-in-time arrival, and also time negotiation related to the port call. The IMO reference model is a conceptual model, not a technical model, which means that it must be mapped to technical data models for implementation. Currently, the IMO reference model is mapped to the data model of WCO, the World Customs Organization, and the UNEC model, and also the ISO data model 28005 on electronic port clearance. The IMO reference data model needs to cover different domains, which means that a framework is needed to handle extensions to the model. The controlling documents are the legal basis for the reporting requirements and the data exchange between actors engaged in the port call. The IMO dataset is a list of common data elements defined across all domains relevant for a port call and a voyage. The reference framework can be structured in sub-models covering specific topics, for instance, static information about the ship, cargo, dangerous cargo, health, maritime services, waste, crew, passengers, timestamps, and the port call itself, among others. Next, various types of actors must be defined. Use cases are the different domains that the data elements and submodels may be used for. Examples here are for reporting on the FOL forms, just-in-time arrivals, certificate reporting, mandatory ship reporting, among others. For each use case, a description of the relevant acknowledgement responses must be included. Across each of the domains and systems, common guidelines on electronic signatures, metadata on message exchange, sequences, and similar properties to ensure safe and secure data exchange must be described. This includes guidelines for setting up each of the types of systems, for instance, guidelines for setting up maritime single windows, guidelines for the exchange of operational data needed for a port call, and guidelines for how to use the proposed maritime reference framework to interface terminal operation systems. The implementation-specific tasks include the development of technical standards, message formats, and APIs. Already existing examples here are the mappings that are described from the IMO reference data model to the UNEC, WCO, and ISO 28005 data models. In addition to the definition of a data model, it's important to define the stakeholders related to the data and the roles that they fulfill. It's also important to describe the processes where this data is used. This can typically be divided into ship operation, cargo operation, and operation in the port and terminal. In addition, the data will have a lifespan that covers marketing, sales and alignment, planning, and execution and completion. And for the IMO reference data model, the planning phase and the execution phase are the most relevant. In this paper, we wanted to highlight the need to have the involvement of all the main stakeholders related to a port call to be able to set up a reference model that ensures that it will be widely used. Also, agreement across the different domains are needed, both reporting to authorities, nautical information, and port operational data. A common reference model is a starting point for ensuring efficient reuse of data and to ensure clear interoperability between the systems. In addition, a clear description of the system interactions is needed. Thank you for your attention.
Thank you, Marianne. The floor is now open to questions for Marianne. cannot see anyone online. Questions? Anyone from the audience? It seems not. In that case, thank you, Marianne, and